Okay, so this one's a conditional probability, which means chance of something given some other event. So I gave you a definition, but that's probably not making any sense right now. So let's just go to the question. So number one is just regular chance question. What's the chance that a student failed the test or randomly selected student would fail the test? So out of 120 students, how many failed? Well, this is the total who failed. So 21 failed out of 120 students. So that's the answer, which you need to, it's better to just change to decimal number. So 21 divided by 125 is 0.175, which is 17.5%, but we don't use percents anymore. It's just children's stuff. We'll just leave it in decimal numbers, okay? So now number two. What's the chance that a student who failed the test got less than 6 hours of sleep? So now we're talking about smaller group. Out of the students who failed the test, okay, so what's the chance that somebody who failed the test, you know somebody failed, what's the chance that he or she got less than 6 hours of sleep? So fail is the total number now. Out of the students who failed, which is 21, so out of 21 students, how many actually got less than 6 hours of sleep? So that would be this group. Not the 15, but 15 is one who passed. But only out of the students who failed the test, what's the chance that that person got less than 6 hours? So that's 12 out of 21, which is 0.5714. So about 57%. Okay, so same thing on, well, now it's different. Number three, what's the chance that a student who got less than 6 hours of sleep, so out of people who got less than 6 hours of sleep, so there's 27 out of 27 students. So a student who got less than 6 hours of sleep, what's the chance that he or she had less than 6 hours of sleep? So that would be still, out of these two groups, that would be 12. Still 12, but the bottom numbers changed. First case was out of the students who fail, what's the chance? Third question is, number three is, out of people who got less than 6 hours of sleep, what's the chance? So the bottom numbers changes. Okay, so that's the important thing. So that would be 0.4444, about 44%. Okay, so number four is different. So if you compare number number 2, 3, and 4, the top number is always 12. So number 4, what's the chance that student got less than 6 hours of sleep? 15 and 12, those are the two groups. And at the same time, had less than 6 hours. So it's small detail in English words, but it makes big difference in numbers. So this is people who got less than 6 hours of sleep, and at the same time failed the test. Okay, now it's the bottom number. What is this group out of? Well, it's not talking about out of those people who slept less than 6 hours, not out of the group whose fail is out of the total group. It's out of 120, which is 0.1. That would be the answer. Okay, so if you notice, number 2, 3, and 4, they always start with the 12 on top, and then the bottom number could be out of 21, could be out of 27, or could be out of 120. So those are the three situations. Okay, now number 5, what's the chance there's going to be a retake for those who either failed the test or had less than 6 hours of sleep? What's the chance that either you had less than 6 hours of sleep or you failed? So that's either or case where it's you gotta add all the numbers. Okay, so who are the people who could retake the test? Well, if you failed, you're allowed to retake the test, and if you slept less than 6 hours, I don't know, you had some emergency and you couldn't sleep, less than 6 hours. So that group will also be able to take the test. So it's like two groups, but you do a union of them. You combine them together. Okay, but you don't count 12 twice. I know 12 overlaps, but out of the 120 students, these three groups of people are allowed to do a retake, or if they want to. So total number of retake that's possible is 15 plus 12 plus 9. 12 and 9 failed the test, and 15 and 12 got less than 6 hours of sleep. So if you put it together, it's 15 plus 12 plus 9. You don't add 12 twice. It's the same people. Okay, so the total number for the OR is either 15 or 12 or 9. Add them all up, divided by 120 again. Total number of people. So anytime that the bottom number changes is if you have that bar, the given. This is a bar. Okay, that changes the bottom number, the denominator. Other than that, it should always be 120. So if you have that bar, that means out of the people who only failed, so like that's why we use 21 in the number 2, or out of only people who only slept, that's why we use 27 in number 3. But other than that, it should always be 120 is your bottom number. So out of 120 students, how many either had less than 6 hours of sleep or fail? So 15 plus 12 plus 9 is 36, divided by 120 is 0.3. Only about 30% of the people are allowed to retake the test. Okay, so that's how that bar works. The conditional probability makes the number smaller than the grand total, which is 120. Makes the number out of only 21 group or 27 in a group, makes it smaller. That works the same way with the decimal numbers. These are same situation, but just divide everything so you get like decimal numbers, like percents. So instead of saying 100 and let's see what's instead of saying like 15 people passed and has less than 6 hours, we take the 15 and we divide it by 120 and we get 0.15. So we just change the numbers, but it's the same situation, so we just work it out the same way. Okay, and you notice that 6 and 7 should be same answer as number 2 and 3. So just work it out. It should be the same. When you have an AND, the bottom number is still 120, but the top number, you need a group that's more and fail. So that would be, these two groups would be more. Well, which one is more and fail? Well, this is more and pass. This is more and fail. So it's, not 120, sorry. Bottom number is 1.00. So more and fail is 0.075. Okay, but in this case, the bottom number is not 1.00. Bottom number should be like these numbers, one of these numbers. Okay, backside. Yeah, this one that I want to talk about. So there's late, on time, and domestic and international. When you have number 16 through 19, the bottom number should always be 1. Okay, because that's the grand total. So for example, let's say number 17, what's the chance that a flight is on time? Well, that's bottom number is 1. And on time, well, there's these two groups that are on time, whether it's from international or from domestic, those are on time. So if you add those, you get that. So 0.9 over 1 divided by 1 just doesn't do anything. So these 4 questions, you get the bottom number being 0.1. Okay. However, if you get number 20 through 22, yeah, 23 is also 1. For these, the bottom number keeps changing. So for this one, international is the given, is the bottom number. So out of the international flights, which is right here, out of 0.3333, what's the chance that it's going to be late? So out of these international flights, what's the chance that the flight is going to be late? This is on time. 0.3 is on time. So that would be late arrival. So that's 0.0333. So work that on a calculator. I'm sure that's going to be 0.1, I think. No, it's not. Okay, let me calculator. Be 0.0999. Okay, we'll just go with that. Right, and then this one. What's the chance? Well, out of the late flights. So late flights is these two guys. So out of those two, it's going to be 0.1 in the bottom. See how the denominator changes because of the second part? So given that flight is late, so you know that plane came in late, what's the chance that it's from international, not from domestic? Well, that would be this number. Same number again, 0.0333. But it's not the same answer. Okay, 0.0333 divided by... It should be 3.3333. Okay, different answer. And this one, domestic. Out of the domestic flights, well, how many are domestic flights? Right here. So that would be 0.6667. Out of that number, what's the chance that it's on time? So if it's coming from, domestic within the United States, what's the chance it's going to be on time? That's 0.6 out of that. So you work it out. I'm sure it's a slightly different number. 0.6667, that would be 0.89995. I guess it rounds up to 0.9, but we'll just leave it. Okay, so the condition of the bar makes the denominators smaller or smaller than the total, grand total, which is 1. But if you don't have any bar, like in this case, it's not a bar situation. It's what's the chance it's on time or domestic? So denominator is still 1, just like number 16 through 19. Okay, but what's the difference? Well, when it's an or, what's the chance that when you find a plane, it's either on time or domestic? Well, now you gotta add up all the numbers that are... Well, that looks kind of confusing. Let me erase all that. So if you find the flight, what's the chance that it's on time or it's domestic? So on time is these two. Domestic is these two. So you just add all 3 of those numbers and you divide it by 1. Okay. I know you're thinking there's another way, but you don't need to use the other way. Okay. So just use that. So when you see the or, it means you're going to add different categories, different entries. So 0.0667 plus 0.6 plus 0.3, everything divided by 1. And I'm sure you're going to get the answer, which happens to be 0.9667. Okay. Yeah, I'll write it. So that's the condition of probability. It makes the denominator smaller because it's given something else. It's not out of the total group, it's out of a smaller group. Okay, so like what's the chance that you're pregnant? Well, probably, I don't know, 1% of the population. But if you say what's the chance that given that you're a man, that's a 0%, right? Okay, different number, different population. Okay, have fun.